Welcome to The Explainer. Today, we are taking a massive, eye-opening reality check on what is absolutely our greatest sci-fi dream, teleportation. We're talking no magic portals, no dimensional rifts. We're just looking at the hard, totally fascinating, and honestly sometimes terrifying science of bridging the void. I mean, it's a wondrous thought, right? If we can send gigabytes of information instantly across the globe, why on earth can't we just send ourselves? For as long as humanity has existed, we've had this deep, burning desire to completely eliminate distance. Section 1. The Dream of Teleportation. Conquering Space. Okay, let's dive into this. To really understand why we want to teleport so badly, you have to realize that our entire civilization has literally been defined by movement. Think about it. Ancient travelers crossed continents on foot. Then ships connected our oceans. Railways shrank nations. Aircrafts compressed the globe into just a few hours. And finally, the internet reduced communication delays to fractions of a second. So looking at our history laid out like this, teleportation doesn't even feel like magic anymore. It kind of feels like the inevitable next step, doesn't it? Section 2, Quantum Teleportation Explained, Physics versus Fiction. So, to figure out if teleportation is actually possible, we've got to look at the absolute reality of 20th century physics. Specifically, we're talking about quantum entanglement. Imagine two particles created together in a very special way. Once they're entangled, measuring one instantly determines certain properties of the other, literally regardless of how far apart they are across the universe. This mind-bending phenomenon isn't some crazy science fiction concept. It's the actual, real-life foundation of genuine teleportation. And honestly, it is so deeply bizarre that it troubled even the greatest minds in history. Albert Einstein famously called it spooky action at a distance. He strongly suspected something had to be missing from quantum theory because it just didn't make sense. But experiment after experiment confirmed it. Entanglement is a real, workable physics principle that we can actually manipulate. So how do physicists actually use this? Well, let's walk through the classic Alice and Bob analogy. Step 1, Alice and Bob share an entangled pair of particles. Step 2, Alice has a target particle she wants to teleport. She measures it alongside her entangled particle and sends Bob a tiny amount of ordinary, classical data. Step 3, Bob receives that data and applies a specific mathematical operation to his particle. And finally, Step 4, Bob's particle perfectly assumes the exact quantum state of Alice's original particle. The information has transferred perfectly without a physical particle ever actually crossing the void. So the crucial point is this: we are moving states, not particles. The original particle absolutely didn't fly through the air to Bob. Quantum teleportation transfers encoded information from one place to another, while the physical matter stays right where it started. And get this, we've actually achieved this in the real world over hundreds of kilometers using satellites. But again, it is purely quantum information. Section 3. Rebuilding a human being. The wall of physics. Now, what happens when we hit the massive, imposing wall of physics and try to scale this incredible quantum phenomenon up to biology? Let's think about teleporting a simple coffee mug. It looks basic, right? But it contains trillions of atoms all interacting through quantum laws. Capturing its physical state is an absolute nightmare. Now, compare that to teleporting a human being. We aren't just a static block of matter. We are an unimaginable complexity of cellular and neural networks that are constantly firing and constantly changing. To put a hard number on that complexity, an average human body contains approximately 10 to the power of 28 atoms. That is a 1 followed by 28 zeros. Every single one of those atoms would need to be perfectly scanned, perfectly recorded, and transmitted for you to safely arrive on the other side. Trying to do that introduces a terrifying stack of physics barriers. First up, the information problem. Heisenberg's uncertainty principle literally tells us the universe forbids us from measuring certain properties of a particle simultaneously with perfect precision. So we can't even get the blueprint. Then, if we somehow magically got the blueprint, we hit the construction problem, which is reassembling you atom by atom. And finally, the energy problem, courtesy of Einstein. It is just overwhelmingly, ridiculously complex. Digging into that construction problem for just a second, we are talking about nearly 40 trillion cells, hundreds of billions of neurons, thousands of kilometers of blood vessels. A machine doing this wouldn't just be an advanced 3D printer, it would require manufacturing capabilities completely beyond modern comprehension.
It would have to place every single atom in incredibly precise biological locations, mid-chemical reaction, without skipping a single beat. And the energy required to pull that off? Oh boy. The raw math of E equals mc squared is totally unforgiving. If you completely convert the mass of a 70-kilogram human into energy, the output literally rivals large nuclear arsenals. Even if we don't fully convert you to energy, just manipulating matter with atom-by-atom precision on this massive scale makes teleportation a civilization-level energy crisis. It's not just a fun tech challenge. Section 4. The Ultimate Identity Paradox. The ultimate question. But hey, let's assume we actually solve the physics, the energy, and the construction. We immediately arrive at something far more unsettling. I want you to think deeply about what this theoretical machine is actually doing to you. If it scans your body, literally destroying you at the atomic level in the process, in order to build an identical, perfect copy on the other side of the world, are you still you? Or did the original you just die? The new person walking out of the receiver has your memories. They have your childhood. They have your exact laugh. They deeply believe they are you. But does your stream of consciousness seamlessly hop across the void? Or does your unique, subjective awareness end right there in the scanner?
This perfectly highlights the terrifying divide between the external observer and subjective experience. To anyone watching on the outside, the copy behaves exactly like the original. Your friends and family wouldn't even know the difference. But subjectively, the original individual may have permanently ceased to exist. Philosophers and neuroscientists debate this constantly, and right now no scientific experiment on Earth can resolve whether this is actual transportation or just a really advanced lethal replication machine.
Section 5. The Future of Distance. Bypassing biology. Given those incredibly grim physical and philosophical roadblocks, let's pivot to something a bit more visionary. What if we bypass these biological walls altogether? One major workaround avoids moving or destroying matter entirely: wormholes. According to general relativity, space-time itself is flexible. So instead of blasting your atomic data across the galaxy, you just bend space to connect two distant points and simply step through a doorway. However, while mathematically possible, no wormhole has ever been observed, and stabilizing one might require exotic forms of matter that might not even exist. So, where does that actually leave us? Consider this. Humans once dreamed of flying by flapping artificial wings. Instead, we invented airplanes. And this brilliantly illustrates how history works. We almost never solve our grandest dreams the exact way we originally pictured them in our heads. Instead, we find technological substitutes that achieve the exact same practical benefits. Just think about the alternatives we're developing right now. We have brain-computer interfaces, hyper-realistic virtual reality, we're exploring digital consciousness models, and remote robotic avatars that you can control seamlessly from across the planet. Combine these technologies with near-instant global networks, and future generations might never need to physically move their biological bodies at all. The entire subjective feeling of distance could just be completely eliminated. The reality is, when it comes to true teleportation, we stand exactly where early humans stood when looking up at the stars. We can clearly imagine the destination, we can even glimpse a few underlying principles in our quantum labs today, but actually walking that path, that will require multiple scientific revolutions across physics, AI, neuroscience, and energy generation. Which leaves us with this final question. When we finally uncover that path, centuries from now, will the future of distance be far stranger than fiction? I highly suspect it will be. Keep wondering, keep questioning, and I'll see you next time.